All right, part 3, welcome back. First things first, here's the part that I'm going to be dealing with today, or in this video. I have an x squared term, an x, and a number, or a constant, okay? X squared, x, and a constant. This is a trinomial, where we have 3 terms. These other ones here were binomials, okay? Trinomial, binomial. So if you see trinomial, think factoring. We're factoring this, okay? And into those 2 binomials that we're used to. All right, here we go. We did that, on to something like this. Now, I want to equate this to graphing and intercepts because I think that helps understand why we're doing this, okay? Pencils down. I'm going to do this one for you. If we graph this, there's my graph there, right? We do negative b over 2a, find that axis of symmetry, plug it back in, etc. Now, what if I told you that if we factored this, we would have y equals to x plus 6, x minus 3. You're like, I know how to do that. I'm an expert at factoring, right? Okay. I want you to take a look at the graph and see, where do you see these points? X plus 3, x minus, or x plus 6, x minus 3. Well, first of all, I have my y-intercept. We're pretty familiar with y-intercepts. And my y-intercept is negative 18. I see that right here, right? Negative 18. But I can see there's a 3 and a 6 here at 3, 0. That's an x-intercept. And negative 6, 0 is an x-intercept. So remember how to find the y-intercept here. You plug in 0 for x. That was the easy part, right? To find the x-intercept, we need to plug in 0 for y. Okay, 0 for y. But it's not that easy, because if this first equation here, I just told you 0 equals x squared plus 3x minus 18, and I said find the values of x that make this whole right side of the equation equal to 0, it might be pretty difficult, right? I can't come up with any just off the top of my head. And that's why we factor it into something like this, because once we factor it to something like this, if we have that equation equal to 0, now, again, remember, all we have to do is set each factor equal to 0. We get x plus 6 equals to 0, x minus 3 equals to 0, x equals negative 6, x equals 3. Well, there's my x-intercepts, all right? X equals negative 6 here, x equals 3 here. So that's my easiest way to solve these quadratics, to find the zeros of the function. Okay, but we can call them zeros. We can call them roots. But these x-intercepts are pretty important, okay? So that's why we're doing this. Let's take a look at just one together. And it looks like this. All right. Steps here, these are good. Write these down. Circle them, highlight them, remember them, sing a song about them. For step 1, set an equation equal to 0. Step 2, factor out the GCF if you can. If you can. All right, can't always. Step 3, factor into 2 binomials. Step 4, set each binomial equal to 0 and solve your equations. All right, here's the one we're going to take a look at. X squared plus 3x equals 18. Now, let's try the first 2 methods that we learned just to see, hey, can we do them? No, we can't. But the first one, if we had tried to take the square root of both sides, we would have x squared equals to negative 3x plus 18. If I take the square root of both sides, square root of that, no, can't do it, okay? So type 1, the version 1 that we saw, can't do it. Can't take a square root of both sides. Okay, step 2, maybe we can take a GCF. All right, set it equal to 0. I'd have x squared plus 3x minus 18 equals to 0. Okay, at this point, my GCF, I have, let's see, 1, a 3, and an 18. The largest number that divides in each one is a 1. Okay. Now I have an x squared and an x and no x's, so I can't pull out any x's. So my GCF is just basically 1, which isn't a fun GCF because you're still left with x squared plus 3x minus 18. Okay, so try to pull out a GCF, but that doesn't really get us anywhere because we're still left with this. All right, so what we have to do, good old factoring into trinomials, we're going to turn it into two binomials. Remember, trinomials 3 terms, binomials 2 terms, okay? All right. If you remember from last week, I'm looking for, because I have a 1x squared, this is the easy type, two numbers that add to 3 multiplied to negative 18. So right away, if it multiplies to a negative, I know my signs are going to be plus and minus, and I'm going to start with an x and an x, okay? My factors of 18, what two numbers multiply to 18? Well, 18 and 1, 9 and 2, 6 and 3, 5, that's about it, okay? Now, I just want to look which ones are ever going to get to 3x. 18 and 1, no. 9 and 2, that's either going to be 11 or 7. 6 and 3 do, right? Now, they have to add to 3x, so I need a positive 6 and a minus 3. So I have x plus 6, x minus 3 equals to 0. All right, factored. We factored it. Now, don't stop here. This only helps us solve, okay? Because I have two values of x that are going to make this equation equal to 0. One of them is when I set x plus 6 equal to 0. And one of them is going to be when I set x minus 3 equals to 0. When I solve these two, I get x equals negative 6 and x equals positive 3. There we go. All right, if we plug those back into our original equation all the way up here, in for x and in for x, those are the two numbers that would make that equation true. All right, we did a lot today. We learned how to take the square root of both sides. We learned how to take out a GCF, and we learned how to solve by factoring a trinomial. Great job. Go ahead and answer a couple more and then come back to the Google Meet.